Hi guys, today we're going to be looking at how to solve exponential equations algebraically using a logarithm. And what you see across the top here are three questions, three equations that you guys solved a couple days ago, and the directions I kept them the same. It says solve using guess and check. So a lot of you, you're doing a good job with that. All right, so like on that first one, you had to say 10 raised to what power, and you were guessing, and the directions say round to the nearest hundredth. Okay, so 4, that's a little too small. I need 14,517, and as you eventually get closer to the answer, 14,000, that's a little big, and eventually you get to that, which is a little small, and then when you try 4.17, that's a little big, and then 14,517, which one's closer? When you used 4.16, that gets you a little closer. Of course, we could keep going out more and more decimals, and that would get us more accurate, but since the directions say round to the nearest hundredth, we've done that. Okay, so once again, when we're solving these equations, we're always going to know whether we're right or wrong just based on does it make the statement true. Okay, so um, what we're going to be looking at in this video together, we're just going to kind of talk through these first three sections, and then this bottom part here with 6 questions, that's going to be your practice that you'll want to submit in Google Classroom. Okay, so right here, you might be saying, why are those questions even part of this? Well, I'm in Algebra 2. This is like easy stuff for us. So but I just want to, I'm not even going to end up solving all these. I mean, we'll just talk about them. But remember the idea of inverses. Inverses undo one another. So like if we're trying to figure out what x is, what makes the statement true, many of you can probably look and say, oh, 36 minus 11 is 25. Or maybe you just say, well, I want to undo a subtraction 11, so I'm going to add 11 to both sides. So we use the addition operation to undo subtraction. On this one, 4 is being multiplied times x, so we're going to undo the multiplication using division. Again, I'm not solving those. This is just a reminder of how we figure these things out. And then I'm just going to rewrite this just to keep my work neat. And so we have the square root of x equals 9. Well, how do we undo a square root? We square it. And why do we have to do it to both sides? To keep the balance of the equation. So this one would be what? X equals 81. Check it. Square root of 81 is 9. This one would be what? X equals, we could just say 21 fourths. Why? Plug 21 fourths in here, and it says a true statement. 21 equals 21. Plug in 36 here, and it makes it true. Okay? So we know addition undoes subtraction, division undoes multiplication, squaring undoes square roots. We've talked about it, we haven't used it necessarily yet. What undoes an exponent? A logarithm. So I'm just going to show you the algebra behind what's going on here. And again, just to keep my work neat. So how do we undo this exponent? We take the logarithm of both sides. And there's different logarithms, but the one we're going to use is this one right here. You see it on your calculator. You probably didn't even know it was there, but log stands for logarithm. And there's different base logarithms. This logarithm on your calculator is base 10. It's also called the common logarithm. How do you know it's base 10? Well, if you look at the exponent that's right above it, see how that says 10 to the x? 10 to the x is going to undo a logarithm base 10 is going to undo an exponent base 10. Look up here, you can actually see this. See how the square and the square root are together? That's because they're inverses. A log base 10 and an exponent base 10 are inverses. So that's what we're going to write down on our paper here. We're going to take the log base 10 of both sides of this equation. Okay, so that's how that looks. So I'm going to allow this logarithm to undo the exponent. So I'm going to rewrite this exponent out front. We'll talk about the properties eventually, but now's not the time yet. So we'll get there though, probably either tomorrow or Monday. So I'm going to rewrite this as x times the log base 10 of 10 equals the log base 10. I'm going to have to write small here. Of 14,517. So look at this. What does logarithm mean? We know logarithm, we've talked about it a couple days ago, means logical number. So what logical number do you have to raise 10 to get 10? And the answer to that's 1. 10 to what power gives you 10? 10 to the first power. Okay, so this expression right here is 1, x times 1. So that's x is the log base 10 of 14,517. So here's our calculator. I'm just going to take log base 10. Notice your calculator doesn't show the base there, but we just have to know that it is base 10 when you use that button, when you use this button on your calculator. Okay, so this is the log base 10 of 14,517. And look at what the result is, and we'll round to 2 decimal places. 4.16, just like we got up here when we guessed it and checked. Okay, 4.16. So x is approximately 4.16. So here's what I'd like you to do now. You did this problem a couple days ago, guess and check. The answer is 7.03. That's what exponent would make this statement true, 7.03. In a minute, pause the video and see if you can work through the algebra on this one just the same way we did right here. Okay, so I'm just going to rewrite this. 1, 2, 3, 4, 5, 6. 123,456. So undo that exponent, take the log base 10 of both sides, and go from there. Take a minute and pause that. Really, pause it. If you're just still staring at the video, you're not being active, pause it, and then we'll talk more about it. All right, good job. So we're going to take the log base 10 of both sides. That logarithm is going to undo this exponent. So I'm going to rewrite it out front. So here's what it looks like. I'm going to write small. Okay, so notice what we have here. On this one, what logical number do we have to raise 10 to get 10? And that was a quick answer of 1, and that was because the exponent was a base 10 and the logarithm was a base 10, so that worked out nicely. This one, not so much. So we're going to have to actually plug in both of these on our calculator. So we need to figure out what the log base 10 of 5.3 is. So here's the log base 10 of 5.3. I'm going to write that down to like 3 or 4 decimals. I'm going to say 0.724. 0.724. And then over here, log base 10 of 123,456. And I'm going to write that down to a few decimals as well. 5.092. So 5.092. Okay. Now to get x by itself, we're going to divide both sides by 0.724. And so let's see. So we're hoping for this, 7.03. Let's see how that works out. 5.092 divided by 0.724. 7.03. Okay, next one over here, number 9. Oh, look, it's a different. It's not exponential. This is logarithmic. Okay, so what we're going to do here is think about what a logarithm is. It says what logical number, here's the logical number, x is the logical number we have to raise 3 to get 321. So I'm going to rewrite that exponentially. X is this logical exponent that we have to raise 3 to get 321. Take a minute and work through that. Pause the video if you want. And you should get an answer of about 5.25. Okay, let's check. 3 raised to the 5.25 power. That's 320 about. 321 is what we were looking for here. But if you try 5.26, that's going to be a little further away from 321. Not much, okay? But 5.25 is the closest answer. I didn't show the algebra here. I want you guys to try that out and see if you get that answer. The algebra from here, take the log of both sides, log base 10, just like we did here, and work through that. So practice that. If it didn't work out, just stop by my office hours and ask me, and we'll go through it together. And then here is your practice down here. These 6 questions. Show your work. I just want to make sure you're working at understanding this information. All right, guys, good luck.